Hello, thanks for inviting me. I'm glad being here. Much attention is now being paid to digital technologies, internet, robots, etc. And we often hear that digital technologies have entered our lives, but digital technologies don't have legs to walk on. So, their creation and implementation in our lives and in engineering are entirely connected with human activity and human capital. Managers highly value digital technologies, but they underestimate the role of engineering personnel. The development and intensification of the use of digital technologies, big data, artificial intelligence, and robotics is currently a global trend. However, this doesn't exclude the use of human labor in most of engineering processes. Engaging human capital to solve problems in engineering is essential for generating value based on digital technologies. It's the people who knows how to use them that generate these values. For this, engineers staff need the appropriate digital skills. Technology often evolves faster than engineering and management personnel can adapt to it, leads to digital transformation failures. Management often underestimate the importance of investing in the human capital of engineering staff as it lacks sufficient metrics to confirm its effectiveness, level of influence on the use of digital tools, and the ultimate result of companies' activities. The purpose of our study is to summarize approaches and to propose a single framework of digital metrics to justify the high importance of engineering personnel in the effective use of digital technologies, as well as the value of investments in human capital based on the generalization of individual disparate metrics. The framework includes metrics which should measure the outcome and economic impact of using a digital tool by staff who have digital skills. We have grouped the metrics by usage, so I would like to present the metrics of our framework as breakdown of these groups. The first group is the metrics to assess the direct impact of new skills on the quality of work, in which we have included the following. Digital skill application rate, which assesses the degree of application of digital skills in work processes that demonstrate how actively engineering personnel use them in practical work. The time-saving level for routine tasks metric, which shows how digital skills allow engineers to perform a routine task faster, ensuring increased productivity and efficiency. Second group represents the metrics to assess the effectiveness of engineers' use of modeling tools to create high-quality digital assets. We include the following metrics in this group. Model Fidelity Index, which shows how accurately the digital model reflects the behavior of the real physical system, which indicates the level of depth of staff skills in modeling and indicates a high competence in the results of digital modeling. A data-driven decision time, which assesses the level of data science skills and analytical thinking speed of engineers, their decision-making speed due to digital twin accuracy, as well as the skill to strategic analysis and predictive thinking. Third group is the metrics related to hybrid skills. We included the following metrics in this group. Interdisciplinary integration error rate, which assesses their degree of usefulness of staff, interdisciplinary awareness, and interdisciplinary integration. Automation coverage rate, the value of which indicates that engineering teams have skills to work with software development and support cycle and machine learning models. Fourth group is the metrics on the degree of staff openness to the use of new technologies. We included the following metrics in this group. Adoption rate, which determines the actual degree of integration of digital technologies into daily work processes. Time to proficiency, the metrics for measuring the time interval needed by an employee to achieve a target level of productivity or competence when working with new digital technology. A level of attendance and completion of training courses, workshops, which measures the active participation of staff in training programs that provide the necessary knowledge and skills for mastering and using digital technology. Generative design usage level allow to assess the level of digital maturity of the engineering team and the actual level of integration of generative design in the design workflows. Fifth group is metrics that measure the quality of collaborations, communication effectiveness, and data integration. We included the following metrics in this group. Engineering alignment score, which allows assessing the team's ability to work cohesively in the context of digital transformation and the application of generative design. Inter-team response time, which allows to assess the effectiveness of communication and coordination within teams, which is critical for fast and adaptive digital processes. Data availability score, metrics for assessing the actual availability of data, which directly affects the efficiency of engineers' work. AR enhanced decision-making rate, which allows assessing the ability of engineers to make effective decisions with the support of AI. Automated data flow rate determines the effectiveness of data integration in digital teams and data preparation for generative design. Sixth group consists of the metrics of economic impact and accumulation impact of decision. We included the following in these groups. Cost avoidance, a metric determining the amount of cost that can be avoided through more accurate, informed decisions made by engineers using data, models, and simulation, demonstrating the benefits of having digital competence engineering staff. Level of cost saving in engineering processes from using digital skills, which assesses the economic impact of using acquired digital skills due to cost reductions in design and other engineering processes. Digital upskilling ROI to measure the return on investment specifically aimed at developing digital skills and competence, and to justify the effectiveness in investment in human capital. Cumulate economic impact of engineering decisions, which determines the cumulative economic effect in decision made by engineers based on digital competence, data, and modern tools over a certain period. A value of improved accuracy of decision, which measures the additional economic benefits gained from improved decision-making accuracy, in particular forecasting, data analysis, engineering models, compared to the previous level of accuracy thanks to new digital skills or tools used by engineering personnel. 7 group is metrics for measuring the effectiveness of decisions made based on data and digital skills. We included the following metrics in this group. Decision accuracy, which measures how much the decisions made by engineers using digital skills reduce the number of error, incorrect decisions, and incorrect assumptions, since increased decision accuracy directly correlated with improved business results. Rework rate measures the ability of engineering personnel to effectively use digital tools to make the right decision that avoid or reduce the work, which is termed reduces unproductive costs. The 8th group is metrics of long-term value rated by personnel. We have included the metrics in this group: engineering attributed net profit, which measures the increase in companies' profits achieved through the use of digital technologies by engineering staff to create new products. We have included 1 metrics in these groups for now, but the proposed system will be expanding with other metrics in accordance with the business specific and development of digital technologies. The proposed system of digital metrics shows to managers the possibility of quantitatively assessing the effectiveness of staff acquisition of new skills and investments in human capital. A change in attitude towards the value of human capital and an increase in investment in its development leads to improvement in staff skills, the effectiveness of their use, and the economic effect of applying digital skills. Thanks for your attention.